Hey guys, it's Miss Vinson. Today we're going to talk more about elasticity of demand. Specifically, how the elasticity of demand changes along a downward sloping demand curve and how that's related to total revenue. Now you've been practicing with the midpoint method formula, so take a look at the chart that we have on the page. This chart has different price values and different quantity demanded values. If we wanted to work out the midpoint method to find the elasticity coefficient between each of these price ranges, then we would just do the midpoint method from row to row. So the first midpoint method problem would be price going from $6 to $5 and quantity demanded going from 0 to 1. The second midpoint method problem would be price going from $5 to $4 and quantity demanded going from 1 to 2. So if you feel like you want a little extra practice with the midpoint method, go ahead and hit pause on the video and try to find the elasticity coefficients in each of these price ranges. Alright, now let's talk about what's happening with the elasticity coefficients. Notice that our elasticity coefficients are really big at first, and then they start to get smaller and smaller and smaller. So at the top of our chart, notice how our elasticity coefficients are all greater than 1. But as we keep going down the chart, they flip and they actually go less than 1. They actually go inelastic. Now let's see what this means on a graph. Let's take our price and quantity demanded numbers and just do a real quick sketch of a downward sloping demand curve. So at each price level, you would plot the quantity demanded, and then you would connect those dots and have a downward sloping demand curve. Now what we're going to do is we're going to take those elasticity coefficients that we have in our chart and we're going to put them on our picture at the correct price ranges. So from the price range of $6 to $5, our elasticity coefficient was 11. So what we're going to do is we're just going to put an 11 over that price range. From $5 to $4, our elasticity coefficient was 3. So we're going to put a 3 right there over that price range on our demand curve. So as we continue down our demand curve, putting our elasticity coefficients at the correct price ranges, we notice that everything on the top half of the demand curve looks like it's all greater than 1, and everything on the bottom half of the demand curve looks like it's all less than 1. The conclusion that we can draw here is that on any regular downward sloping demand curve, your elasticity is not going to be the same along the curve. Part of your curve is going to be more elastic than the other part. So in a regular downward sloping demand curve, the top half of that demand curve is always going to be the elastic range. If you were to do the midpoint method on any of the price ranges in the top half of a downward sloping demand curve, you will always get an answer greater than 1. So the top half of a demand curve is always considered the elastic portion. Likewise, notice how the bottom half of our demand curve had all of our coefficients less than 1. So on a downward sloping demand curve, if you were to do the midpoint method on any of the price ranges in the lower half, you would always get an answer less than 1. You would always get an inelastic answer. So the bottom half of a downward sloping demand curve is always considered the inelastic portion or the inelastic range. Well, when you go from greater than 1 to less than 1, at some point you have to cross and hit exactly 1. So unitary is always going to be right in the midpoint of your demand curve. If you were to do the midpoint method right there at that particular price range that was at the center of the demand curve, you would get an elasticity coefficient that was equal to 1. So make sure you're familiar with the elastic range of a demand curve, which is the top half, the inelastic range of a demand curve, which is the bottom half, and the unitary point of a demand curve, which is the midpoint. You may have to label those on some free response questions. Now let's talk about something called TR, or total revenue. Total revenue is all of the money that a seller is bringing in whenever they sell their items. So, if you were part of a club at school and y'all were selling carnations for Valentine's Day at school, suppose you were selling those carnations for $1 each. Now maybe today you chose to volunteer to sit at lunch and sell carnations for your club. At the end of lunch, you had some friends come up to you and say, "Hey, how much money did we bring in from the sale of our carnations today?" Well, you may have sold 30 carnations, and you were selling them for $1 each. So how much money did you bring in total? You brought in $30. Total revenue is simply the price of what you're charging times the number of things you sold. Total revenue is always price times quantity. But also notice it's revenue. It's just the money that the seller is bringing in. This is not the money that the seller gets to keep for profit. We'll talk about that later. This is just their income. Well, let's go back to the numbers in our chart and let's figure out what the total revenue values are in this chart. Now, for total revenue, all you need to do is multiply your price times your quantity. And notice in our chart, we have that information. So we're going to multiply our price column times our quantity column, and we're going to get our total revenue values. Now check it out. As we start going through and finding our total revenue values, you're going to start to notice a pattern developing. Notice that your total revenue values start to increase, but then at the middle of the chart, they kind of hit a high point and they start to turn and fall back down the way they increased. If we were to graph a total revenue curve, then it would basically have a parabolic shape, or it would look like, a rainbow if you wanted to think about it like that. It's going to increase at first and then it's going to fall and decrease. Now take a look at our chart. Total revenue seems to be at its highest point right there at the middle of our chart, right there where it looks like we're pretty close to unitary. So here's what we're going to do. We're going to line up our demand curve with our elasticity zones to our total revenue curve. This is a sketch that can be extremely helpful for you, and sometimes this can help you to avoid doing the midpoint method to try to figure out if demand is elastic or inelastic. So when we line these two graphs up together, first we want to have our downward sloping demand curve with our elasticity zones. So we're going to have our elastic area, our unitary point right in the middle, and our inelastic area. And then on the graph below, we want to draw our total revenue curve, which is a parabola, but we want to make sure that that total revenue curve is at its highest point when demand is at unitary, when demand is at midpoint. So very important, make sure your total revenue curve is highest when your demand is at its midpoint. Now, why would total revenue go up at first and then turn and fall back down? Well, there are only two things that can change total revenue. That's if the price changes or if the quantity demanded changes. In the elastic zone, in the top half of the demand curve, when a seller changes their price, when they lower their price and put things on sale, people have a strong reaction. So since consumers are having such a strong reaction to that price change, the increase in quantity outweighs the decrease in price and total revenue goes up. So notice that in this half of the graph, price and total revenue move in opposite directions. If you lower your price on the demand curve, consumers are going to have a strong reaction. You're going to sell a lot more, and that's going to make your total revenue rise. If you were to raise your price in the elastic range, well, customers are going to have a strong reaction to that price hike. And even though your price is going up, your customers are having a strong reaction and buying a lot less. And so that's going to make your total revenue go down. So price and total revenue move in opposite directions on the elastic range. If you lower your price in the inelastic range, if you put your things on sale and go down the demand curve in the inelastic range, well, customers aren't really reacting very strong to that sale. So your decrease in price is really not being offset by a large increase in quantity demanded. So in this case, you're lowering your price, but people aren't really buying that much more. So basically, you're just kind of losing money. So when you lower your price in the inelastic range, your total revenue is going to fall. So price and total revenue move in the same direction in the inelastic half of this graph. And finally, just remember at unitary, that's where your total revenue is at its highest point. Now, sometimes you might have questions that give you price data and quantity data. And it'll ask you, is demand elastic, unitary, or inelastic over this price range? So it'll be a really great multiple choice question on an AP exam. They give you a little bit of data, and one of the answers could be elastic, B could be inelastic, C could be unitary, D could be perfectly inelastic, E could be perfectly elastic. Now, one of the ways that you can find the answer, you can always rely and fall back on the midpoint method and see if your coefficient is greater than 1, equal to 1, or less than 1. But the midpoint method kind of does take up a little bit of time and space. So if you want to avoid the midpoint method, then you can always look and see what has happened to total revenue. So you could take those numbers and you can multiply your price times quantity at the old price level and your price times quantity at the new price level and just see what happened to total revenue when your price changed. If your price went down but your total revenue went up, then you know that the demand is going to be elastic. If your price went down and your total revenue also went down, then you know that demand is going to be inelastic. Okay, let's work an example together with some numbers. Suppose that the price of something drops from $50 to $40. So the price level is going down from 50 to 40. Now when the price was $50, suppose that there were 300 people buying the item. But now that the price dropped to $40, there are 400 people buying the item. Well, we could do the midpoint method, but we could also just multiply price times quantity and figure out what's happening with our total revenue numbers. So at a price level of $50, the quantity demanded is 300. At a price of $40, this company is selling 400 units. So check it out. When their price went from $50 to $40, when they put their things on sale, they actually increased their total revenue. So since price fell and total revenue increased, since those two things moved in opposite directions, we can conclude that demand is elastic over that price range. Until next time, guys, I'll see you later.